In this problem, two equiconvex lenses of focal length f each are kept coaxially in contact with each other. Coaxially means these lenses share a common axis. Now, for this system of two lenses, the equivalent focal length is f. Now, when the gap between the lenses is filled with glycerin, the problem says that the equivalent focal length for the system of three objects, here the glycerin is taken as a lens, the equivalent focal length is f2. We are asked to find the ratio of the focal lengths. So we know that when we keep two or more lenses in contact, the equivalent focal length 1 over f can be obtained by taking the sum of the reciprocals of the focal lengths. So we can have more than two lenses in contact. So without glycerin, you look at the two glass lenses. So the focal length is 1 over f1 is 1 over f plus 1 over f. So this is 2 by f. So we can say the equivalent focal length is f over 2. Now, when I fill the gap between the glass lenses with glycerin, so let's say we put glycerin here. Now this glycerin would act as a concave lens. So for the glass lens, if f is the focal length, the glycerin lens will have a negative f focal length. Okay, so this is because the radii of curvatures is same. It's just that if you go by the sign convention, the positions of the center of curvature for the convex lens and the concave lens, they are oppositely directed. So for glass lens, if the focal length is f, for the glycerin lens, we can take it as minus f. Now for this system, the effective focal length is f2. So if I take 1 over f2, I can write it as, for the glass, 1 over f. For the glycerin as a lens, it is 1 over minus f. Again glass, 1 over f. So if you see, I think two of the terms will cancel. So here f2 is f. So if you take the ratio f1 over f2, you should get by 2 by f. So that is 1:2. So the correct answer is 1:2.